Welcome, dear students. I'm as a geometrical problem solver. In the figure, O is the center of the circle, and you have to prove that angle POR is equals to twice of angle PRQ plus angle QPR. Now see here in the figure, POR is composed of two angles, POQ and angle QOR. These two angles. Now see here, another angle is PRQ. PRQ, this angle and this angle are on the same arc. We can use the relation of central angle and inscribed angle. Another angle QPR, QPR and QR is also in the same arc, but one is at the center and another is at the circumference of the circle. So we can easily verify this. So now let's start. Given, what is given in the question? O is the center of the circle. Always remember that given to prove, and sometimes we need construction also. Now what do you have to prove here? To prove angle POR is twice of angle PRQ plus angle QPR. Okay, after analysis of the figure, you can write here directly statements and regions. We do not need any construction here. Statements and regions. Statement 1, angle POQ. Angle POQ is twice of angle PRQ. POQ, PRQ, both are in the same arc. That means what you can write here, central angle is twice the inscribed angle standing on the same arc. Standing on the same arc. Okay. And the next one, angle QOR. QOR equals to twice of angle QRP. QPR. And QOR. They are in the same arc QR, but one is at the center and another is at the circumference. So what we can write here? Same as statement 1. Okay. Now see here, right side, PRQ plus QPR. PRQ plus QPR. Now that means you have to add this two statements in order to verify it, in order to find the result. In order to obtain this result, you have to add this two statements. So adding statement 1 and 2. In statement number 3, we can write here angle POQ plus angle QOR equals to twice of this angle here, angle POQ plus angle QOR equals to twice of angle PRQ plus twice of angle QPR. With region, adding statements 1 and 2. To obtain the result, we have added statement 1 and 2. Now from here, POQ plus QR equals to, this angle will be equals to angle POR whole part region, and right side is same, PRQ plus angle QPR. Region is here. What is the region? Whole part axiom. Using whole part axiom in statement number 3. Whole part axiom in statement number 3. Whole part axiom in statement we can use this. So finally, we verified it using the relation. Now see the next question. In the figure alongside chords MN and RS, circle intersect externally at point X. This point is X here, and the two curves MN and RS intersect at external point X. And you have to do that MXR. This angle is equivalent to half of arc MR minus NS. So now let us see the figure MR and NS. These two arcs are in the right hand side. That means you must find an angle, or you must make an angle standing on the arc MR as well as NS. For this, we can join either M or S or N or R, whatever you like. कुनै एउटा आर्क हामी point M र S लाई जोड्न पनि सक्छौं अथवा N र R लाई जोड्न पनि सक्छौं, because we have relation between central angle and opposite arc or inscribed angle and opposite arc. Center छैन भने चाहिँ हामी central angle बनाउन सक्दैन, के बनाउनु पर्यो, you have to make inscribed angle. Either you can join here M and S. These two lines are joined, two points are joined. M र S लाई join गरे है, M र S लाई join गरे भने MR arc मा यो angle बन्यो, ठीक छ, and NS मा कुन angle बन्यो, यो angle बन्यो. Okay, now we can find the relation between them. यसको बीचमा हामी रिलेसनहरु निकाल्न सक्छौं. हामीसँग रिलेसन छ के भन्दाखेरि inscribed angle is equivalent to its opposite arc. Inscribed angle भनेको opposite arc सँग equivalent हुन्छ. भनेपछि तपाईहरु, so what is given here, chords MN and RS intersect at external point X. At this angle MXR is formed. External point of formation. What do we prove here? Angle MXR is equivalent to half of MR minus NS. So we need construction here. Construction verification information are insufficient. Construction join MS or NR. Join N and S are join. N or S join. You point like one. Arc MS angle value, MR angle value, arc NS mark angle value. So now, statements and regions. Statements, regions. Before that, see here. Up here, U angle, relation. These two angles are inside the triangle NXS, and this angle is exterior angle. And remember one theorem related to exterior interior angle. The exterior angle of a triangle is equals to the sum of two opposite interior angles. Opposite interior angle, with angle to sum. The exterior angle is equal to. Two relation is person. Relation is also arcs. So it's statement number one by angle MSR. MSR is equivalent to half of MS. MR. Half of MR. Can write this? What is the reason? Relation between inscribed angle and its opposite arc. Inscribed angle and opposite arc. Okay, we have this relation between inscribed angle and opposite arc. Similarly, another inscribed angle is here NMS. Another angle is here NMS. So we can write here in this statement number 2 angle NMS. NMS is equivalent to half of NSR. What is the reason? Same as statement number 1. Now in number 3, we have to verify, we have to find the relation between these three angles. Therefore, we can write here MSR equals to angle XNS plus MXS. Angle MXS. See? MSR, this is an external angle. XNS, this angle, plus MXS. What is the reason? The exterior angle of a triangle is equal to the sum of two opposite angles. The exterior angle of a triangle is equal to opposite interior angle. Is equal to sum of two opposite interior angles. Is equal to sum of two opposite interior angles. Now in number 4, if you combine these all statements 1, 2, and 3, MSR angle MSR equals to, what is the value? XMS. MSR, we have the relation. Finally, what we have to put there? You have to prove MXR. MXR, MXS, both the same angles. So from this, you can write here MXS equals to MSR minus XMS. We have only interchange here. In order to verify, we have to prove that MXR equals to, so number 4, from statement 3. Yeah, but yeah. So now finally we can prove it. MXS and MSR are the same. MXS or MXR, both the same angles. So we can write that MXR is equivalent to half of MSR is equivalent to half of MR minus NMS. NMS or XMS, whatever you like. NMS and XMS, same angle. So what you can write here? NS. From statement 1, 2, and 4. From statement 1, 2, and 4. Okay. In this way, we can verify this. In this way, we can verify this. Finally, we got the result. Okay. See, another question. In the figure, O is the center of the circle. O is the center here. And C and D are entry points in the chord AB. Chord AB में C and D बनने points are. And what is given there? AC equals to BD and AM equals to BN. Arc AM is equals to arc BN. That will prove that angle ACM is equals to angle BDN. So I can prove here arc AM equals to arc BN is given here. But these three angles ACM and BDN are not either they are not on the circumference or not, neither they are on the circumference nor they are at the center. So we don't have in relation directly. I'm saying direct relation छैन किनभने सेन्टरमा पनि छैन सर्कमफरेन्समा पनि छैन बाहिरको पोइन्टमा छ भने चाहिँ हामीले सुरुमा अर्कै तरिकाले त्यसलाई मोडिफाई गर्नु अब अर्को के दिएको छ एसी र बीडी इक्वल दिएको छ है त एसी र बीडी इक्वल दिएको छ अब यहाँनिर हामीले यदि कन्स्ट्रक्सन गर्यौं if you join A and M A र M लाई जोइन गर्यो B र M लाई जोइन गर्यो दुईटा ट्रायंगल बन्यो ACM र BDN यो दुईटा ट्रायंगललाई कन्ग्रुएन्ट देखाउन सक्यो भने के हुन्छ वी क्यान भेरिफाई कन्ग्रुएन्ट देखाउनलाई give it a particle value. You arc equals how many? Chord one equal हुन्छ, you can equal है. अब यदि यो एंगल र एंगल इक्वल आयो भने यो एंगल हामीले यो एंगल र अर्को किनभने सर्कमफरेन्सको एंगलसँग रिलेसन चाहिन्छ आर्कसँग. So now at first you must verify these two angles. AM भन्ने आर्कमा MN जोड्यो AMN हुन्छ, त्यसमा यो आर्क हुन्छ. BN भन्ने आर्कमा MN जोड्यो फेरि यो आर्क हुन्छ, यतापट्टि यो एंगल हुन्छ. यो एंगल इक्वल आउँछ, यो साइड अलरेडी इक्वल छ, यो साइड इक्वल छ भनेपछि के भयो त SAS एक्जनबाट बी द ट्रायंगल के हुन्छ कन्ग्रुएन्ट हुन्छ. कन्ग्रुएन्ट ट्रायंगलको करेस्पोन्डिङ पार्ट्स इक्वल हुन्छ. So now at first write on the given from the question but O is the center of the circle. O is the center of the circle. C and D are 2 points on the chord AB. Chord AB means AC equals to BB and AM equals to BN. You have to prove here. To prove angle ACN is equals to angle BPN. We take equals. Now we need a construction here. Construction line and like given point AM and B. A and M joining. Join A and M. A and M. B and N. A and M join B and N. So now the first step. First number 9, giving some statements and regions. Number 1, AM equals to BN. AM arc is equals to BN arc. Region is BN. Okay, now add here. Number 2, finally we can write here R AMN or AMN equals to R BNN. BNN. If MN is added to AM, we get AMN. If MN is added to BN, we get BNN. So what is the region here? Adding MN R on statement number 1. On both sides of statement number 1. Both sides of statement number 1. Adding these 2 arcs. Adding these 2 arcs on both sides of statement 1. So now number 3, you can write here angle AMN. An angle is ABN. ABN is equals to BNN. This number of angle is the MAB or the BAN. Inscribed angle is standing in the equal arcs are also equal. Inscribed angles on the equal arcs are also equal arc number को inscribed angle it gives a equal. Okay. ऐसामा अब हामीले हेर्नु पर्यो अब ट्रायंगल लिने दुईटा ट्रायंगल कुन ट्रायंगल लिने भन्दाखेरि in triangles A and C and B and D. The triangle number 1, AM equals to BN. What is the region? Which R equals to how many? Just number of coordinate equal. Number 2, angle ABN equals to angle BAN. Number 2, that particular the angle ABN equals to BM from the statements 3. Okay. 3 number, right? Number 3, AC equals to BD. AM equals to BD. AC equals to BD. What is the region? SAS. So now in number 5, triangle AMC is congruent to triangle EMD. What is the region? 5, SAS action. If two triangles are congruent, then obviously corresponding angles will be equal. Number 6, angle ACM, angle ACM equals to angle BDN. Region corresponding angles of congruent triangles are Thank you very much for watching this video. फेरि अर्को कक्षामा म अन्य समस्याहरू लिएर आउनेछु। Have a nice time.